Hey everyone, welcome back to ThermalGuru. In today's video, we'll compare two of the most widely used temperature sensors in the industry, the RTD and the Thermocouple. By the end of this video, you'll clearly know which one you should use based on your application. Let's get started. Basic concept. Both RTDs and thermocouples measure temperature, but the way they do it is completely different. RTD, resistance temperature detector, measures temperature by detecting change in electrical resistance of a metal, usually platinum. Thermocouple, on the other hand, generates a voltage when two dissimilar metals are joined together and exposed to heat, known as the Seebeck effect. So one works on resistance change, while the other works on voltage generation. Working principle. Let's look at how each sensor actually works. RTD. In an RTD, the resistance of platinum increases linearly with temperature. For example, a PT100 has 100 ohms at 0 degrees Celsius and around 138.5 ohms at 100 degrees Celsius. By measuring this resistance change, we calculate the exact temperature. Thermocouple. A thermocouple consists of two wires made from different metals like chromyl and alumyl in a type K thermocouple. When the junction between them is heated, a small voltage, in millivolts, is produced. The higher the temperature difference, the greater the voltage generated. Temperature range. Now, let's talk about temperature range, one of the biggest differences. RTDs usually operate between minus 200 degrees Celsius to plus 600 degrees Celsius, depending on their construction. Thermocouples can go much higher, up to plus 1800 degrees Celsius, especially type B, R, and S thermocouples made from platinum and rhodium. So if your application involves extremely high temperatures, a thermocouple is the better choice. But for moderate temperature ranges, RTDs are more accurate. Accuracy and stability. When it comes to accuracy, RTDs are the clear winner. RTDs offer excellent repeatability, stability, and linear output. Thermocouples, while versatile, tend to drift over time and are slightly less accurate, typically within plus or minus 1 to plus or minus 2 degrees C. That's why RTDs are used for precise control and calibration, while thermocouples are preferred for wide temperature ranges and fast response. Example. RTDs are commonly used in pharmaceutical, food, and lab environments where accuracy is key. Thermocouples are used in furnaces, engines, and metal industries where high temperature is more important than precision. Response time and durability. Thermocouples respond faster than RTDs because they are smaller and lighter, perfect for quick temperature changes. However, RTDs are mechanically more fragile and need protection against vibration and shock. Thermocouples, on the other hand, can survive harsh environments, high vibration, and even corrosive gases, making them rugged and reliable in heavy industry. Cost and maintenance. In terms of cost, RTDs are generally more expensive due to the platinum element and precise construction. Thermocouples are cheaper, easy to replace, and available in many types K, J, T, S, R, B. However, RTDs require less frequent calibration, while thermocouples may need recalibration after continuous high-temperature exposure. Comparison table. Let's summarize everything in one simple comparison. Parameter RTD thermocouple. Working principle resistance change voltage generation. Temperature range minus 200 degrees Celsius to plus 600 degrees Celsius minus 200 degrees Celsius to plus 1800 degrees Celsius. Accuracy high, plus or minus 0.1 degree C to plus or minus 0.5 degree C. Moderate, plus or minus 1 degree C to plus or minus 2 degree C. Response time medium fast. Durability moderate high. Cost higher lower. Best for precision measurement high temp applications. Conclusion. So, Which one should you use? Choose RTD if you need high accuracy and stability. The temperature range is below 600 degrees Celsius. You are working in lab or process control. Choose Thermocouple if you need fast response and rugged performance. The temperature exceeds 600 degrees Celsius. You are working in furnaces, kilns, or engines. Both sensors have their own advantages. It all depends on your application's temperature range, accuracy requirement, and environment. So that's the complete comparison between RTD and thermocouple sensors. If you found this video helpful, hit the like button, subscribe, and turn on the notification bell for more temperature sensor tutorials. Thanks for watching. This is ThermalGuru, making temperature easy to understand.